We're going to add to our summary notes in the front of our binder, and we're going to talk about quadratic functions. And we've talked before with this table of values here that this center point right here, the center of our table, was the turning point or the vertex of our graph, and that the shape is U-shape, and it can open down or it can open up. You can add those details there. In words, we talked about from the beginning of the year that the rocket launch problem is an example of a quadratic function. We looked at some other examples. And it doesn't have a constant rate of change because it's curved. Only a line has a constant rate of change. So now we're going to sketch what the parent graph looks like and talk about the equation. We have graphed previously and talked about how the parent function is just y equals x squared. So our h and k are 0. So our vertex is at 0, 0. The coefficient of x squared, or our a value, is 1. And so it has this basic shape here, and you're going to connect that with a smooth curve. And you'll notice some of the key characteristics here are that the vertex is at 0, 0. So hk in this case is 0, 0. And we said that our a value is equal to -1. And you notice that all quadratic functions are this U-shaped curve. This is called a parabola. And it's symmetric. It's as if you put a mirror right here down the y-axis, and that there are mirror points that are equal distance. So if we folded that graph in half, it would lie completely on top of each other. And there is that word. The shape of the graph is called a parabola. And this is where the axis of symmetry would be. Mark that on your paper. We are going to look at the vertex form of the equation. This equation is what we call vertex form, where we have y equals a times the quantity x minus h squared plus k. And we discovered that hk correspond to the vertex. So h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. And keep in mind, this negative in the equation is built in, which means what you see here, the h value, is always the opposite of the sign that's in the equation. The k value goes right in, so make a note to remember that. And a affects whether our parabola opens up or down. If a is greater than 0, that means a is positive. The graph opens up, so it's a smiley face. If a is less than 0 or negative, the graph opens down, so it makes a frown if you look at it that way. And the a value also affects the width of the parabola. So how narrow or quickly it goes up, or how wide it opens up. The last thing I want to add is over here in the word section, and I want to add some key features. The x-intercept, the y-intercept, and the vertex, just in context. Those are often interesting points on your graph. In one of our opening word problem scenarios that we looked at, we had a ball being thrown, and it was thrown from a height of 1 meter, so maybe a person throwing the ball, and it reached a height of 6 meters at a distance of 10 meters, and then it hit the ground at 21 meters. This is our y-intercept right here. This is our vertex, and this is an x-intercept. And those are all what we call key features. So label those on this page. So in this scenario, the y-intercept right here is the height that the ball was thrown from. The x-intercept right here is how far the ball traveled before it lands at 21 meters. The x-coordinate of the vertex is how far it went in reaching its height, and then the y-coordinate of the vertex is the highest point of the ball, which is 6 meters. I have squeezed a lot of information here in this last section. As long as you have this written down, that is sufficient. You're welcome to write these details in your notes, and I will post this on our Schoology page.